Hello to all the HubLE audience. My name is Tony Sorial. I'm an academic orthopedic surgeon based at Newcastle University in the UK. I'm the co-chair of the HubLE Meet the First Author initiative. I'm here today to present our first edition of Meet the First Author with my fellow co-chair, Jonathan Gustafson of Rush Medical University Center in Chicago. And now we're here today to discuss your paper published in the May edition of the Journal of Biomechanics entitled Development and Validation of a Kinematically Driven Discrete Element Model of the Patellofemoral Joint. To begin with, could you tell us a little bit about the background of the work?
Yeah, I'd be happy to. So this work really actually started back in 2011 before I even started my PhD program. It's really the epitome of collaboration between two very different disciplines, one physical therapy and the other bioengineering. So during my PhD at the University of Pittsburgh, I took on this project where our goal was to come up with a new technique to be able to quantify patellofemoral joint contact stress distribution during dynamic activities and range of motion. And so the reason we wanted to do this is because osteoarthritis is a huge musculoskeletal problem. It's a degenerative joint disease of the cartilage. And a primary cause for this degeneration of the cartilage is due to joint contact mechanic changes. And for us as researchers, we need to have a good, reliable way of quantifying changes in that contact stress distribution. So for us, it was really important to try and come up with a way to do this because there's no existing way to be able to analyze or assess how the joint contact stress changes in individuals when they're doing activities of daily living.
Okay, so Jonathan, how big of an issue is this for patients with arthritis?
Yeah, absolutely. So patellofemoral osteoarthritis is a huge problem. 1 in 3 adults over the age of 50 years old actually develop signs, radiographic signs of patellofemoral OA. And one well-known precursor to the development of arthritis is having symptoms or issues of patellofemoral pain. And pain we know is very much related with essentially how the joint moves and the contact stress profile and how that changes during dynamic activities. And so for us, this is really important for us to understand how we can assess joint contact stress distribution and how our rehabilitation treatments are actually changing the mechanics of the joint.
And a really interesting and relevant area of study, I have to say, Jonathan, and I know from my personal perspective, we see plenty of patients in the clinic with patellofemoral joint pain. So can you tell us a bit about what your work and your papers added to our understanding of the problem?
Absolutely. So the new technique that we really wanted to implement was that we wanted to take computational modeling with advanced methods for assessing or evaluating joint motion. Most computational models today, for those familiar with the finite element method, include using estimations and approximations of joint muscles and moments and how these all contribute to the mechanics at the joint itself. Whereas what we were interested in developing was using a discrete element technique, which is much simpler, involves far fewer computation time, and ultimately uses the patient's own movement patterns to actually prescribe the motion for the model. So basically this gives us a little bit more accurate picture of what's happening to the joint and gives us a diagnostic, or more importantly, a quantitative way for evaluating the stress that's going on during that motion. And so for this paper in particular, we wanted to be able to validate this using a very durable and good way of evaluating this was in a cadaver lab. So being able to control all of the different constraints and be able to look at dynamic ranges of motion in the cadaver lab.
Okay, great. And what do you think the relevance will be to the patients, to the public, for other researchers? Where do you think the most relevance from this paper is going to be?
So this was really a methodological paper, kind of a proof of concept that we can actually employ this technique using patients' kinematics to be able to drive these models. And in our case, we used a cadaveric model. And so for us, the next step is actually applying this to patients that we collect data from who have patellofemoral osteoarthritis as well as patellofemoral pain, so both older and younger adults. And for us, we're really interested in being able to develop not only new rehabilitation techniques, but actually be able to track individuals and patients long term by being able to quantitatively evaluate how their stress, joint contact stress is changing throughout these dynamic activities. And so the next step for us is applying this within these individuals, which we've actually already collected all that data, and I'm currently writing up a paper to publish over the next month or so that looks at those results from individuals with patellofemoral OA.
Okay, that's great. I'm sure we'll have you back for the second paper then to hear a bit more about it. So in terms of your future career and your goals, how will your publication help you to achieve those aims? What is your career trajectory and how does this tie into that?
So currently I'm a postdoctoral researcher at Rush University Medical Center in Chicago. And really here at Rush, our emphasis is on translatable medicine. So being able to take concepts from basic science research and really apply them to the patients and be able to make lasting outcomes for them. And so for me as a researcher, early stage in my postdoctoral training, I'd really like to become an independent investigator who's emphasizing the ability to be able to take patients' own motions and how their joints move and be able to come up with techniques, rehabilitation treatments to be able to get them out of the clinic sooner, be able to have pain-free activities of daily living, and ultimately return to sport. So I work with a lot of athletes as well who come in with frequent patellofemoral pain and other symptoms. And so for us, it's really important to be able to get these individuals back doing what they love and they enjoy.
So from the sounds of it, it sounds like this paper, although it's very early work, could have direct patient benefit in future and to a lot of patients.
Absolutely. So this is just kind of one of the complementary tools in science.